Okay, so welcome to the question 13. Here now it's 10 mark for part A, two parts to it, A and B. And part A here's fairly handy, actually part B so is too. And part A says use trigonometry to work out the value of x in the diagram below. Give your answer correct to 2 decimal places. So first impressions, this is a right angle triangle. So I have an angle, this will be my opposite, okay? This is my hypotenuse, and this is my adjacent, okay? So I'm going to flick over. So I've labeled them there, the opposite, hypotenuse, adjacent. Now I'm looking to find the x value here. I'm looking to find the adjacent. So the formula could be cosine, okay, which would be useful if I had the adjacent and the hypotenuse. I don't have either of them, so cosine won't work. Now if I look at the tan ratio, okay, I have the angle, okay, so I have that. I have the opposite 6, and I'm looking for the adjacent. Okay, so if I put the figures in, so tan of 20 is a number, and it's equivalent to 6 over something. We're looking to find out what that something is. So do some algebra, bring the x across. It was divided on the right, becomes across, becomes multiplied. Now I want x on its own, not tan 20 times x. So bring the tan 20 back across, becomes divided. So 6 divided by tan 20 can go through the calculator. And as long as it's set to degrees, I get a decimal of 16.484. Now it goes on for longer, but I just shortened it for simplicity. Now I want this to 2 decimal places. So the 4 here is less than 5. The next number stays the same. So 16.48. They don't tell us what the units are, but I'm putting in that they are units. That's part A, 10 marks. Okay, so very straightforward trigonometry. Now part B is a little more challenging in how it looks. Okay, almost reminiscent of Leaving Cert. Honours, whatever, in basic Leaving Cert honours. And it says here that a different right angle triangle is shown on the right. It has sides of length A, B, and C. One of the angles is Y. So then it says in this triangle, A plus B is greater than C. If you add the sides A and B, they're going to be greater than C. And use this to prove that cos of Y plus sine of Y is greater than 1. Okay. So I've just started here now. I've written out I've labeled, first of all, the opposite is the side across from the angle we're looking at. The adjacent is here, and then the hypotenuse is along the side. Now I've written out sine and cosine, the ratios, okay, and I've basically compared them. The opposite of hypotenuse, okay, is the B divided by C. Plus the sine is the. Actually, I just realized I got these not wrong, but mixed in the wrong order. The adjacent over hypotenuse is the cosine, and the opposite over hypotenuse is the sine. So they're just kind of the wrong order, but that doesn't matter. A half plus a half is the same thing either way. So if I put in the letters then, so B over C is the same thing. That's the opposite over hypotenuse is the same thing as the adjacent over hypotenuse. The adjacent is A, and the hypotenuse there is the C value. Now I can express them as a single fraction, the denominator C, and then the next step here, I'm just bringing the C across the inequality, so it becomes multiplied on the far side, okay, and it becomes C times 1 just becomes C. So B plus A is greater than C, and that's been proved. Okay, so that's question 13. Thank you, and see you on question 14.